Page 762, number 17, part A only. Use the limit definition to find the slope of the graph of the function at the indicated point. So we're going to use the definition that we have of a limit, which is the limit as x approaches our value, in this case is -1, of our change in s. So in this case, let me write that as change in f over change in x. So we are going to have our function, forgot our limit. We're taking the limit. So we're taking the limit as x approaches -1 of our function. So some arbitrary point that we're going to move closer and closer to -1. So the value of that point minus our value at that exact point. So those are our y2 minus y1, and then we're going to have x minus a -1. Okay, so again, like one of our earlier examples, we are going to leave the x in our limit definition because we want to be able to change that as x is approaching -1. So our function is 2x squared. And we're going to subtract that from that, the value when we substitute -1 into the function, and we get 2, and that's going to be over x plus 1. And just like previously, we want to simplify the fraction. So the limit as x approaches -1, we can factor out a 2. And again, we want to keep going. The idea is we are hoping that the limit exists. So as we get closer and closer to -1, we have to be sure that this fraction exists. And if we make x arbitrarily close to -1, we're going to end up with a fraction that does not exist. So after I factor out the 2, I can see that I have a difference of squares that factors. So I'm going to have x plus 1 times x minus 1 times that 2 all over x plus 1. And now what I can do is I can cancel these factors because I'm not allowing x to equal -1. So the denominator is not 0. So I can cancel it out, divide it out. So that leaves me with the limit as x approaches -1 of 2 times x minus 1. So now I can look at that function, and as x gets arbitrarily close to -1, it's approaching the idea that I can substitute -1 in for x and get a value. And when I do that, I get that the limit is -4.